today we're going to look at function notation. What I want you to do is consider the function y equals 2x. Now you can do the vertical line test on the graph to know whether it is a relation or a function. Well, I can tell you it's a function because it's a straight line. When we cut the vertical line down it just cuts it once, which means it's a function. Now let's have a look at this. We can see that y is a function in terms of x. So we can abbreviate this using function notation. We use f, open bracket x, to say we are going to put a function in terms of x, and that function is 2x. These two things mean the same thing. This is what we call function notation. And I'm going to show you in this video how we use function notation. So if I wanted to evaluate this function, I might want to find, say, when x is equal to 1. We can use this notation because what we're doing is we're substituting x for the value 1. So then when I work this out, I'm going to do 2 times 1, which is 2. We can say that f of 1 is 2. So we say f of x equals 2x, f of 1 equals 2, f of 0 equals 2 times 0, which is 0. So f of 0 is 0. All right, let's look at some more complicated ones. Let's suppose we've been given a function fx equals 2x squared, take away 3. And we want to find f of a negative number. So say f of negative 2. Well, all we've got to do is wherever the x is in the function, we are substituting negative 2 in. So if I write that just by using substitution, as you can see, wherever the x is, I've placed that in brackets, and obviously I've had to square it because the x is squared in the original function. Now I just work it out using BIDMAS. So minus 2 squared is positive 4, 4 times 2 is 8, 8 take away 3 is 5. We can say that f of minus 2 equals 5. Now you can substitute other things in. You don't just have to substitute numbers in, you can substitute algebraic letters in. So for example, let's suppose I wanted to change the function in terms of x and say I wanted to find, well, what's f of 2a? Again, it's just a substitution thing. All I've got to do is wherever I see the x within the function, I'm substituting 2a in its place. So 2 times 2a squared, as you can see I'm doing 2a squared minus 3, and then we just work that out. So as we've got with index laws, we need to square each part of the bracket. So 2 squared is 4 and a squared is a squared. 4 times the 2 is 8, so I've got 8a squared minus 3. We can say that f of 2a is 8a squared minus 3. All right, now we're going to consider a different function. Let's suppose we've got 2x plus 4. Well, let's suppose we had to find the value of x when we've been given f of x equals 6. Okay, so what we can see here is the function is now equal to 6, but the function is also equal to this. So if we want to solve this, we need to put the two equal to each other because f of x equals 6. So if we're going to solve this, we just say, well, 6 equals 2x plus 4, and then solve for the equation. So obviously I'm going to take 4, giving me 2 equals 2x, divide by 2, leaves me with 1. So therefore, when f of x equals 6, x equals 1. You can also solve for inequalities. You must remember your rules of inequalities. So remember, if you're dividing or multiplying by a negative number, the inequality switches signs. But I don't think I'll do one in this particular instance. Let's use the same function. Let's find all the values for this for when f of x is greater than or equal to 3. So f of x is greater than or equal to 3. So again, I'm just going to use this and put the two equal to, well, not equal to each other, sorry, because I'm using a greater than or less than sign, so I need to remove the equal sign. Apologies. What I'm going to do is put this and this together and form an inequality. So I've got 2x plus 4 is greater than or equal to 3. So solve it as you do normally. I'm going to subtract 4, giving me 2x is greater than or equal to minus 1. Then I'm going to divide by 2, giving me x must be greater than or equal to negative 1/2. Okay, and that's pretty much all you need to know about the basics of function notation.